In number 3, it looks like we're going to do some vector addition, continuing with the same scenario. Mr. Bockert has had a change of heart and decides to chase after one of the students and throw a balloon at them. The student knows that Mr. Bockert won't be able to make rapid turns very quickly due to a condition referred to as oldness. The student goes 3 meters east, then quickly turns and goes 4 meters south. Looking at the situation, you laugh, not because Mr. Bockert's bent over gasping for air due to his oldness, but because you know that he could have stood still and hit the kid at the end of his path. We want to know what the magnitude and direction the balloon would have had to take to hit the student by standing still, working smarter instead of harder. So we're going to draw this out, each one of our vectors. We went 3 meters east, then turned and went 4 meters south. We add our vectors tail to tip. Our resultant vector will be from the tail of the first to the tip of the last. So this will be R. Theta for our direction will be between the first vector and the resultant vector. To solve for the magnitude of our resultant vector, we're going to use a squared plus b squared equals c squared. Plugging in our numbers, 3 squared plus 4 squared equals r squared, which equals 9 plus 16, which will be 25 equals r squared. Take the square root of 25 to get r, and r will equal 5 meters. So that is the magnitude. Now we need to find the direction. To find the direction, we're going to use the inverse tangent of the opposite side over the adjacent. Looking at our angle, the opposite side is 4 meters. The adjacent side is 3, and this will give us theta. Theta will equal 53.1 degrees. Make sure that your calculator is in degree mode and not radian mode. And to give a precise direction, this would have been south of east. And that's number 3.